Okay guys, now that we've just done all the work in learning how to factor and solve quadratic equations, let's talk about what they're going to look like when we graph them. A quadratic equation, first and foremost, in standard form needs to be y equals ax squared plus bx plus c. This is a form that's very nice and neat and organized. It's in order from highest degree to lowest degree, and we can easily substitute numbers in and see what we're going to get back. Now take notice that a, b, and c are all numbers. A is in front of the x squared, b is in front of the x to the first, and c has no variable attached to it. So that's just what we call the constant. When we graph a quadratic equation with a degree of 2, we get back what's called a parabola. Now a parabola kind of looks like a U shape. It can either look like this guy here or this guy here. Now the graph is either going to open up or down. In this drawing over here, which graph do you think opens up? Which graph opens down? So, let's look at these parabolas here and see if we can figure out which one opens up and which one opens down. On number 1, if you'll notice, it kind of looks like a frowny face. It's looking downwards. That means it's opening downwards. Now, in a parabola, the most important point is the vertex. The vertex is what everything is centered around. And to find this point, you have to look at where the graph changes directions. For example, if I were to follow this graph, I'm going up and up and up and up, and then all of a sudden I change directions and I'm going back down. So this point right here where the directions switch, that's what I call my vertex. Now, in some graphs, the vertex is going to be the maximum point, which means it's the highest it can go. On others, it's going to be the minimum point, which is the lowest that it can go. In this graph, since it's on top, it's going to be a maximum point. On number 2, my parabola here looks like a smiley face. Since it's a smiley face instead of this frowny face over here, that means that it opens up. Now again, my vertex is where my graph changes directions. So on this graph, it's down here, which means that it is now a minimum point of my graph. Let's look at this one. Does this parabola open up or down? Great, that means it opens up. Now, since it opens up, does that mean my vertex is a maximum or a minimum? It's down here at the bottom, so that means it's a minimum. On number 4, does this parabola open up or down? This one opens down. So, is my vertex a maximum or a minimum? It's on top here, so it's a maximum. Now, actually, we don't even need to see the graph to determine if the parabola opens up or down. All we need is the equation. Now remember, the equation in standard form is y equals ax squared plus bx plus c. Now, if we look at the a value, all we need to know is if it's positive or negative. If the a value is positive, the parabola opens up like this. If the a value is negative, the parabola opens down like this. So, on this problem here, let's look at the equation. Y equals 2x squared plus 3x minus 6. The a value is 2, the b value is 3, and the c value is negative 6. So from this a value, since it is positive, we can tell that our parabola is going to open up. That means it's going to look something like this. And that also means that its vertex down here is a minimum value. So on this problem, we can look and notice that my a value is negative, and that means it's going to open downwards. If it opens downward, it looks like this, and that means that my vertex is a maximum value. So what about this one? Does it open up or down? This one opens up, which means, is my vertex a maximum or a minimum value? It's a minimum value. It would look something like this. What about number 4? Does this graph open up or down? Notice my A value is positive, so that means it opens up. Does that mean its vertex is a maximum or a minimum value? Hopefully, you notice that it's a minimum value. It looks like this. On number 5, does this parabola open up or down? Hopefully you'll notice that this is negative, so it opens down. Does that mean my vertex is a maximum or a minimum? If it opens down, that means my vertex is a maximum. It should look something like this. Last one, does this one open up or down? This one's tricky. Since the A value doesn't look like it's there, it's actually 1, and that means it opens up because that's positive. So does that mean my vertex is a maximum or a minimum? This means my vertex is a minimum because it would look something like this. Now, since we have learned all about how a quadratic is supposed to look when we graph it, let's actually graph one. Now, before we even jump into that, I need to remind you that the most important point on a parabola is its vertex. Everything is centered around this point. So when we go to graph a parabola, we want to start with that ordered pair, because if everything's centered around it, that kind of helps us make sure that our graph looks right when we're done. Now, to find the vertex, it's actually a nice little formula that we're going to use. X equals the opposite of B over 2 times A. So let's look at this example equation. It says graph the equation of y equals x squared minus 6x plus 4. The first thing they want me to do is identify my A value, my B value, and my C value. My A value is the number in front of x squared, so that's going to be 1. My B value is the number in front of x to the first, so that's going to be negative 6. And my C value is the number in front of no variable, so that's just going to be 4. Now, to find the vertex, we're going to take each one of these numbers and substitute them into this formula right here. So to find the x value of my vertex, we're going to take the opposite of my B value. My B value is currently negative 6, so the opposite of that is positive 6. Then we're going to put that over 2 times my A value. My A value is 1, so 2 times 1 is 2. Now 6 divided by 2 gives me an x value of 3. Now, to find my y value, we want to substitute my result back into my original equation. So, everywhere that I see an x, I'm going to substitute that 3 in there. But remember, whenever you substitute a number, you have to put parentheses around that number. So, y equals, instead of x squared, I want 3 squared minus 6 times 3 plus 4. Now, I know we can put this in our calculator, but let's just practice our mental math skills. We're going to start by taking 3 squared, which is 9, minus 6 times 3, which is 18, and plus 4. Now finally, I can take 9 minus 18, which gives me negative 9, and add that to 4, and I get a y value of negative 5. That means 3, negative 5 is the vertex for my parabola. That's going to go right here, 3, negative 5. Now, another way that quadratics are different from linear equations is that we can't just find the y-intercept, find the slope, and count to see where our line goes. The only way to graph a parabola is to make a table of values and actually plot them on your graph. Since our vertex is the most important point of our parabola and everything is centered around that point, we're going to put that point in the center of our t-chart. Then I can find numbers that are smaller and bigger than this ordered pair and see what happens with those values. So if I go 1 bigger than 3, I get 4, and again I get 5, and again I get 6. We like to have 3 because that gives us a nice amount of points to look at. Let's go the other way too. 3 minus 1 is 2, again is 1, and again is 0. Now, all we need to do is take these numbers and substitute them back into my original equation to see what I get for my y values. Let's start with the number 0. When I substitute 0 into my equation, whenever I put it in for x, we need to put parentheses around it. To help with this, instead of doing everything by hand, let's put it into our calculator. So first I have x squared, so I'm going to put 0 in parentheses squared minus 6 times 0 plus 4. Now when I do that, I'm going to get a result of 4 back, so that can go here. Now we're going to do it again for 1. So 1 squared minus 6 times 1 plus 4 gives me a result of negative 1. And then we can do it for 2. 2 squared minus 6 times 2 plus 4 is going to give me negative 4. Now let's try it again for 4. When we substitute 4 in, we should get negative 4. Now some of you might be a little nervous because that's already what we got for 2, but that's okay because this is not a linear equation. I'm not going to get a line where every number goes to a different number. Some of them might be the same. Let's see what happens when I put in 5. When you substitute 5 back into your calculator, you should get a result of negative 1. Now let's try it again for 6. When you substitute 6 into your calculator, you should get a result of 4. Now I hope you'll notice that this number up here happens to be the same as this number down here. This one here is the same as this one here, and these two are also the same. That's going to happen on every parabola because, like we said earlier, everything is centered around the vertex. This number and this number should be the same, these two, and if we were to keep going, they would still end up being the same numbers. So now we need to graph our parabola. Now, since the vertex is the most important ordered pair, that's the one that I'm going to start with, 3, negative 5. So that means I'm going to go right 3 and down 5 and put my point. Then I'm just going to go one way or the other. Let's start with the number smaller than it. 2, negative 4 would be right 2, down 4. 1, negative 1 is right 1, down 1. And 0, 4 is right 0, up 4. Let's try it now for the bigger numbers. 4, negative 4 is right 4, down 4. 5, negative 1 is right 5, down 1. And 6, 4 is right 6, up 4. Now hopefully just by looking at this, you guys will be able to tell that we can't connect these with a straight edge and call it good. This is not making a straight line, this is making a parabola. So if I put my pencil on the vertex, I'm going to do my best to freehand this parabola to the right. Now, make sure that your line or your graph goes all the way outside of the grid and ends with an arrow because it does go on forever. Then we can do the same thing on the other side. Now, if you'll notice, this makes that nice U shape. It's very important that this is not a V shape, it is a nice curve. It's a U shape. Now notice the parabola is symmetric. It looks like if we were to tear it in half right down the middle, everything on this side would be the exact same as everything on this side. That means there has to be an axis of symmetry in my graph. Now the axis of symmetry is a vertical line that goes right down the center of the parabola. So let's take a second and draw a dashed vertical line down the center of my graph. If you'll notice, this graph, this line goes right through my vertex. That's because the vertex is in the center of the graph. If I were to cut this graph on this line or fold it in half on this line, everything on this side would be the exact same as everything on this side. Now, if I wanted to write the equation of this axis of symmetry, since it's a vertical line, it would be x equals, and since it goes through 3 on my x-axis, it would be positive 3.